Hello guys. So today we're going to talk about connecting a variety of Festo IO-Link valves to a Balluff IO-Link to Ethernet IP master. The IO-Link is the master port. This is a 4-port device. So the top 4 ports are standard inputs. The bottom 4 ports can be configured for IO-Link. The ControlLogix will be talking to the Balluff Ethernet IP device there. And that's about it. So when it comes to the Balluff and ControlLogix, which is the software platform that is used to program the ControlLogix or the CompactLogix PLCs, Balluff offers some AOIs, they call it, so add-on instructions. The website. Let's go to the website here. The website. So there's the website. Maybe I can put that in the link to the YouTube video here. When you go to the Balluff website, this is the IO-Link module, and down here the add-on instructions. These are available right here. So when you download those, you'll get a little bit of a description or a user guide, and you'll get the add-on instructions itself, and so on and so forth. So you download the instructions, and you've got the starting point for the Balluff portion, and for the Festo portion. The support portal, which is this link at the top of the website for www.festo.com, whatever the country is, for wiring information and so on and so forth. So for the valves, just type in the valve. VTUG-12 is one of the valves we're using. You go to the technical documentation, you get the IO-Link installation manuals, so on and so forth. The other valve is 569926. Again, IO port, there's the manual. And basically, download the user manuals for that. At the later part of the video, we're going to talk about a Festo add-on instruction. The Festo add-on instructions are not available on the website, but you can contact technical support, and they'll give you an add-on instruction. Basically, they've got one add-on instruction that works for all their valves. Okay, so we've got the Balluff add-on instruction. We've got the same Balluff website there will give you user manuals for wiring and so on and so forth. And you've got the Festo manuals here. So the next thing is going to be some wiring. So you have got, okay, so these are the 3 valves that we're connecting. They all have IO-Link ports on them. And the IO-Link is a standard, of course, so you've got the standard wiring right here for all the ports. And when it comes to the Balluff module, if you read the manuals, the IO-Link port is marked as so here. And then they've got a power supply module, this right here, the 7/8 pin here, and then the Ethernet at the top. Again, the IO-Link standard cable here. When you use their and use their device to connect to our, or the Festo device. You'll see here that they have a 5-pin, and pin 5 is not used or not connected. On the Festo, pin 5 is the 0. So you need to supply pin 5 on the valve terminals with the 0 volts. So if you buy this particular cable here, it'll blend those two pins together as shown here. Okay, so now to the programming. So I'll take you from the ground up here. So I'm going to select a processor, give it a directory, give it a name. Name cannot exceed 40 characters. Well, all right, so the funny thing is that you can rename your project later in that directory and it'll be longer than 40 characters and it'll still work. So I don't know why they even do that, but whatever. So hit the next button. I'm on version 21 for the time being. What else are we doing here? Finish. That's it. Simple. All right. So it's creating the project. All right. So first thing we have to do is build the backplane. So in order to talk to the Balluff via the EtherNet, so we have to add an EtherNet module. So into TR is what I have here. Add that. Give it a name. Give it an IP address. Of course, this version here will depend on your firmware. And this particular sample, I've got, I think, 5.2. Yes, I'm in slot 3. What else are we doing here? Connection, that's about it. No ring. So you've got the Ethernet master module here. Come down here now. I'm going to add next thing I'm going to do is I'm going to add a generic module. So this is for the Balluff. When you read the manuals for the Balluff, you'll see that you need to add this. Where is it here? Hang on. So new module, generic. There, you have to be selecting the thing that doesn't let you select other things. So generic Ethernet module, create. Give it a name. It has to be of this data type because this is what's in the user manual. Give it an IP address. And these are defined in the manuals here. This is standard. I'll just show you this in the manual here. So here's the manual here. So the manual shows you right here what you're supposed to be hooking up or connecting or configuring. So you've got that configured. So we're going to continue on here. Hit OK. Of course, you want to use unicast. Their manuals don't tell me what the minimum RPI is. And hit OK. That's that now. Okay, what's the next step here? So the next step is to bring in the add-on instruction. So import the add-on instruction. And this is the add-on instruction right here. Import. Hit OK. Normally selecting all the defaults when you're importing will work out for you. So now we've got the AOI for that. Now we need to start adding some code. So in so new routine, give it a name, ladder program. Okay. All right, so add the add-on instruction and then start populating the tags. Give it a name. Now the next thing is how to do the raw data here. The raw data is based on this name right here. So if you go to the controller tags right now, you'll see that these names right here exist. Each one of them has a data reference, which is pretty normal in ControlLogix or CompactLogix. Come on, click. So basically, these names right here are what you're going to use. So copy, input data. Next one is the output data. Copy, paste, and then control data or config data is the last one. All right, so create a tag for this. And the next thing I'd like to mention is this port 1 through 4. So as I detailed earlier, we've got the bottom 4 ports. See how they have got the IO link designation on them? So these bottom ports on this particular IO link master can be configured as IO link. The problem that I have found with the Balluff AOI is that the labeling for the labeling for the ports is typically wrong. So how can I explain this? Okay, so this is how I'm going to explain this. So I took a picture and I marked up something here. So in their user manual, this is their typical overview here. And if you look at their port numbers, which are the ones in black here, you know, port 13 is port 1, 5 is port 5. So everything seems wrong, okay? And then when you get down to the IO link ports, you know, 11 is supposed to be port 3, 10, port 4, it's all wrong. But what I did was I took their AOI and I've added descriptions. And this is the port numbers. So left side is 0 through 3, right side 4 through 7. And what I'm going to do with my code here is name everything accordingly. So port 1 is actually port 2 when it comes to IO link. So IO link, create. So that's port 1 again. This one here is port 2. So this is, they're calling this port 1 the wrong thing. It's port 2. In Logix Designer, we're going to go to the next port. which is port 3. And we're moving down here, so their port reference here, port number 2 is actually port number 3. And then we're going to jump over to the next port. So their port 3 and 4 are 6 and 7 in reality. So we'll go back to the control here. Port 6. You can name these tags whatever you want. I'm just giving it the IP address and the port number. That way it's a little bit logical here. So we just did these 2 ports right here. And the last thing here is this, we'll just call this map data. All right, so we've got the add-on instruction here now. And what I'm going to do here is add a run comment. So again, this is the layout of the master here. You've got the AOI for Balluff. You've got standard port 0 and 1, and then the next port down is the IO-Link port 2 and 3, which we're going to configure as those IO-Link ports later. And then moving top right, we've got port 567 or 4567 top to bottom. All right, so the user manuals that come with the add-on instruction tell you a little bit about what this means, and then there's also quite a few things that you need to do to configure the module. So what I'm going to do here, okay, so what I'm going to do here again is what I said. What I did, I just paused the video for a second and I basically went into the data structure for the generic module here. And the user manuals that are for the AOI, which are located on their website, is this module right here. So when you go through the user manual, this right here is something I've modified myself. This is not what it is. If you look in here, there's a picture behind it. So the wiring installation, eventually you get down to the data configuration. So this area of the user manual describes what every bit, byte, integer represents as far as how their IO-Link master is set up. So this is all in the manual here. You've got that was config data, and then you've got input data, and then you've got output data. So what I've done is this module here, which are these tags. If I go to here, to help me understand a little bit and everyone understand, is I've taken that and I've mapped or given description to all the tags, so that if you're ever confused about something, it's all written right here and so on and so forth. So port validation, you know, every tag's been labeled, and that goes for the all of them, you know, config data and output data, of course. All right, so all this AOI of theirs is doing here is it's manipulating the raw data, you know, these 3 things with each individual port and this tag right here. So the first thing we want to do next is we want to configure those ports, these bottom ports right here. We want to configure those as being used as IO-Link. Okay, the map data tags within the instruction has config data, And I've already populated this for all my projects and given the values, but basically there is a port 1 function right here, okay? And again, when you read the manual, when you configure the port function itself, if you want it to be a IO-Link module, you have to put a 1 right here. So I've configured all 4 ports as IO-Link. And basically, take some code here and add those bits. So give you a little bit of description here. So each port, so again, port 1 in their description, which I cannot change because it's part of their AOI, is actually port 2. And port 2 is actually port 3, and port 3 is actually port 6, and port 4 is actually port 7, just like what I explained up here. Okay? Now, whenever you change anything in the configuration on the Balluff, you need to, of course, dump this into the PLC and throw it into run mode, the PLC, and then once that data has been passed to the Balluff, then you need to cycle power to it so that it basically stores these values and looks at them on startup and then moves on from there. So the next thing you might want to do is look at the status of the ports. Okay, so I've got a couple tags here. I'm just going to drag and drop to make things a little faster here. So the IO-Link status. So these bits are representing each port again. They tell you the IO-Link mode itself, and so port is in IO-Link mode, meaning that it's once you've cycled power, turn it back on, it's actually in IO-Link mode. And then the next status here is device connected. So if you've got the thing configured, it tells you whether you've basically got another device communicating successfully with the module. All right, continuing on with the configuration here, there is a feature that is called validation, and part of the config data is right here in the config data memory map here. So again, in the user manual, talks about validation, and basically, to sum it all up, we've got a validation type. So in the config word, you're basically telling it how you're configuring and what the module is going to expect. So traditionally, it's 0. There's no validation at all. So this would be 0. And on startup, it doesn't check to see if there's a vendor ID or device ID match. Okay. The second one, second option is vendor ID with device ID, and that's what I'm using. And so basically, you need to know what the vendor ID is and device ID. And in this case, I'm using a couple different valves. So the valves will depend completely on what you put here. The simplest way is to basically go online while it's running, look at the data, because it'll give you this in the memory map, and then you can move on from there. So basically, I've got a 1 to say, look at the vendor ID and the device ID, and I've configured the vendor ID. This is what these are. And basically, when you do a cycle start or a cycle of power on the Balluff, it's going to check these, match the configuration to the actual, and if it's good, then you'll get a green light. If it's not, then it'll be sitting there flashing. And what I'm going to do here is I'm going to add a little bit of description here. So these bits right here, again, like port 3 is actually port 6, port 4 is port 7. These, I describe it here, basically give you the status on startup here, which I'll show real time later. And what I'm going to do here is paste in some code. So this code is not required. It's irrelevant. I'm just showing you for each port what they're actually comparing. So validation type is equal to 1. That means that I'm looking for the vendor ID and the device ID. And this port 2 inputs is where the data is coming back from the device. Here, 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 and so on and so forth. It just comes right through contiguously here. The vendor ID must match. If it doesn't match, then you'll get a validation failed, for example. And this is an MPA-L valve from Festo. I don't have anything connected on this one. And I've got a VTUG like I showed you earlier in this. So these just show you that what they're actually looking for. All right, so the next thing to understand is power. So on the Balluff, or where's the back picture here? Balluff. Okay, so the main power for the Balluff, you've got sensor or module power, which is on pin 2, and you've got actuator power on pin 1. Okay, so you always need pin 2, and you always need 0 reference on pin 3. The pin 4 and 1 are optional, and so if you were only connecting up sensors, for example, here, you wouldn't need to worry about the 24 volts, but we're using a valve, so we need the power. So the way the Balluff works is once you've configured these IO-Link ports, you have a bit that turns on the pin. It's pin 2 that we're using actually on each port, okay? And so you need to turn on that. So you can use that based on e-stop. You would have your e-stop wired to the actuator power here. And of course, if you turn on the bit for pin 2 and this pin 1 is turned off, you're not going to get the power and you'll still have a fault. So it's kind of working hand in hand. So the depending on what you want to do with your code, typically you would just want to have the pin up here, which is typically controlled by an e-stop, control the power to the valves that's moving out through pin 2 here. So in the code, you basically have these bits right here. So you've got the map data again. And if you look at the manual, it shows you what all these are here. I'm describing what it is and giving the right reference here. So each one of these bits here turns on the power for each port, which is these 4 ports here. So again, over here, and then like traditionally, there is a status of that same port. So pin 2, map data. I'm just, so the last couple things is to do with the power still. This one bit right here. So if you go to the map data, there's a couple of, there's a UA fault and US fault in the data structure of the AOI. And this particular bit right here will show you the status of this pin 1 right here. And then the last config is this one right here. So this US. So if the IO-Link communication cable has an undervoltage, then this fault will flash. All right, so that's basically it. You would dump this into the PLC, download it, and cycle power to the Balluff. And once the power's been cycled, then it's now set up so that the bottom 4 ports are IO-Link and the device is running. So now we need to be able to manipulate the actual output data. So we're going to add another routine here. All right. And I'm just going to add a reference here so I know what ports are what. Okay, so when you go to the AOI and you go to each port, okay, when you go into that port, just close some things here. So go into that port and you'll see here that there are inputs and outputs. Okay, we're using Valve, so we're not using the inputs right now. We've used the inputs for other things, for vendor ID and so forth. But basically, if you want to just start using their data, you can. But I mean, traditionally, you'd like to kind of compact things a little bit, or do things your own way. That's what I'm going to do and show you here. So if I went in and I didn't have any code and I turned on these bits here, then the outputs will get turned on similarly in the code, the real world. So right here, I've labeled these ports. So port 2, port 3, port 6, port 7, these are my tags here. Give you a little bit of description here. So I'm going to add some code here. So I'm just going to add these tags here. It's just so that there's more descriptive text in the code. We'll leave the ports and stuff. So basically, we're going to map from these tags right here into these tags in the appropriate locations here. And using a bit field distribute, I'm going to move this valve output into the port outputs here at the first byte. This one's going to the second byte, or the same. Sorry, the next 8 bytes with 8 bits within this word here are going to go into the second byte. Third 8 bytes, fourth out. You get the idea. And basically, we're copying from this to the Balluff, which in turn is going out through here and turning on the real world. And I'm going to add some code for the other ports here. So MPA valve, nothing's connected to this port. The VTUG-12 is connected to this port 6, and the VTUG-10 VLK is connected to port 7. So essentially, this tag is going to be used throughout your code to be used as your outputs. And the last thing I want to talk about is error code. So when you went to the Festo website, you downloaded a user manual. And within the user manuals, top here, I can give you just the user manual. You can go to the website, type that in. 802.6491. If I go to here, 802.6491, type that in. There's the manual right here. So in the user manual, there is one little tiny section here talks about the code coming back from, or sent from the valve to the IO-Link master. Okay, what I've done here is that's the VTUG, the MPA-L, which again, there's the manual number there. There's another representation of fault code, and the last one here with my own little note in it. There's the VTUG. Okay, so these are hex numbers. That's why they have the H there, of course, and then the decimal values are 80 and 0 and 81 and 18. So what I'm going to show you here is I'm going to add some code. So alrighty. Add some code. And it's based on port number, so I'm not referencing the valves themselves. All right, so what I've done here, MPA-L codes give you the reference to the manual, and basically, as we said earlier, so we've got a 80 and 81, so 80 and 0 and for the first fault, which is a device error, and then the load voltage, which is common between them all, is the 81 and 18. So in the code, there's the 81, there's the 18, because there are decimal numbers in here, of course. And when you look at the data structure for this right here, you have events, okay? Now, there's 3 events, so basically it's a FIFO. And when you have the error code is basically a status that's coming from the device, from the Festo valves or from whoever. And the error code itself tells you whether it's an active status or an inactive or cleared status. And in my code here, basically if you come in here and there is a 0 in that particular area here, let me just go up to here. So here's the 3 error codes. So if there's a 0 in this event code, so when you were first come in here, it's going to be all zeros when you first start up, because there's never been any problems, so on and so forth. So what I'm looking for here is if that's a 0, then there is no error, and the minus 80 is the device saying the error has been cleared if there was one previously, and the minus 16 is there's an active error at this particular event. I'm only looking at event 1 because event 1 is always the latest. As soon as you get a fault in event 1 and then you clear the fault, the information that was in event 1 gets pushed down to event 2, and it continues like that. So basically, if I have an error active down here, then I look at the code. The code itself matches the manuals, and some of them only have, so this one only has 1, so this is the MPA-L. It only has 1 fault, which is what we're looking at, error in the load voltage. So basically, this load voltage here, which we'll test later, gives you the status. Now I'm just going to populate the code for the other 3 valves. So port 3 is not connected again, and then port 6 has got the VTUG-12, and if you look at the VTUG-12 manual, there's actually 2 fault codes. You've got a short circuit or load voltage problem. So I've got same structure over here, same status for error cleared and not cleared. And if the error is active, then I look at the fault codes, and there's either a device error or a load voltage error. And same thing for the last one, the VTUG. Same idea. Okay, so now we're going to simply download this to our device here. So actually, let's just show you here. So, you've in RS Links, don't know much about Rockwell World. So in RS Links, you configure drivers. You just come in here, add Ethernet devices, Ethernet IV device. You add it, and then it starts running. And then when you go into here, you can browse to make sure you actually are communicating. And these are a variety of PLCs I have in my room, my building. And once you've configured those, when you're in the project and you do Who Active, you can select your PLC. I've already done this. I'm using this L71 here, and you can download right here, but I've already set it as the active project. So I'm just going to download. Defaults. Okay, so for demonstration purposes, this top left port, which is standard input port, I've got a switch connected to that, and turn it back to run mode. And the switch, the input right here is right here. So I've done this on purpose so that I can show what happens with the power. So all these are active right here. And as I mentioned before, the once you have everything active, so I have no validation failed. Once you've configured everything, and like I've already done this previously, that's why I don't have any problems right now. I don't have to do anything, but basically, once you've downloaded this and the program is in a run mode, at this point you want to cycle power to the Balluff. Otherwise, the configuration data is not active and you'll have all sorts of stupid faults. That took me a while to figure out, but that's a nice Balluff. They should have had a big note somewhere in the Balluff manuals, but anyway. So cycle power, and now we're to the stage where we're at right now, and we're up and running. So we are in idling status on all 4 ports, and because I don't have a port connected, so I'm just going to show you the status right here. So I'll disconnect port number 7, the bottom right port. So port 7 has been disconnected, and the connected status goes off. So you can use that in your code however you like, typically to generate a fault. I'm connecting it back up. It's up and running again. I'm not going to show you the validation. It's really straightforward. If I, well, sorry, I could. So let's just say, so this is the configuration word right here. So if I put a 0 right here, okay, which is expecting it to be wrong. So right now I'm going to cycle power to the Balluff. Balluff is starting up, going through its boot up procedure. All right, so Balluff right now, the port number 3, so left side, one up from the bottom, has a flashing red LED on it, and you'll see in the code here that the validation failed is active. So that's the gist of it. So either you put the device ID and whatnot back to the way it should be, or you turn off validation by the configuration word here. So I'm just going to cycle power right now, change that back. Starting up right now. All right, so it's back up and running, green lights everywhere, validation is not failed, so it's all good. So now we scroll down to the output power. So, all right, so what I'm gonna do here is right now, the ports themselves have an LED status for power. So right now on each of the ports, because I have the pin 2 power on and the power coming in, I've got a green LED. It's solid whenever you have a device connected, and I guess a orange yellow. I guess it's orange that represents the power. So if I drop the input so that the power is off, the orange LEDs on each IO-Link port will go off. And each of the valves will have a fault. You know, if you scroll down to the faults here, so error is active, and because the error is active, I'm looking at the appropriate codes here, and I've got error in low voltage. This one here has nothing connected, so it has no problem, and nothing to report, like the device is not reporting back a number, so you're not going to get any problems. This port here, same thing, a low voltage error and low voltage error on this one. All right, I'm going to turn the power back on, and before I do that, I just want to mention you're looking at this fault right here, so that's not on right now. So I'm going to turn this bit back on, and of course these errors have been cleared. Errors cleared. You have no errors. This is the same for all of them. The next thing I'm going to do here for demonstration purposes is on the Balluff, this pin 1 here, okay? I'm going to drop that pin 1 power, and as soon as I do that, this fault should come on, so the one right here. All right, so I'm going to drop the, so right now on the LED status of the Balluff, we've got orange LEDs at each IO-Link port. Drop this out, pin 1's off. I now have a fault, and those orange LEDs are off, and this bit right here is on to tell you have a fault. And when you go to each of the valves, you again have a voltage fault, because you know there's no voltage going to the valve. It's going to say, hey, there's no voltage, and I have a fault. So that's that one there. I'll reset the fault, turn it back on. That's relatively quick. Bit goes off. This one right now, I have this in here. To be quite honest, I really don't know how to test this. I'm just going to keep it in there and add it to my fault list. And I guess if you have a problem, you can talk to Balluff about why that's on or so forth. Now we get to the faults, to the way of controlling the valves. There's really not much to it. If these bits and bytes are used throughout your code, and you turn on the LED status, well, sorry, not the LED, sorry. Whatever bits are on that are mapped to the valves are going to turn the coils on. Right now I've got coils on all the valves. got green lights on all the valves, and that's it. So now we know, or now you know, how the Balluff works with Festo IO-Link valve terminals. This block from Balluff is generic. Well, it's not necessarily generic. I think the reason they have all the port numbers labeled wrong is because it's been made for 8-port IO-Link masters as well as this 4-port. And maybe that's why it's labeled wrong. But I'm just going to show you one other thing here, which is the additional AOI from Festo for the valve banks. And to do that, I'm just going to open up another program here. There's one other thing I'd like to mention here. So I just want to show you the relationship between this right here and the Balluff AOI. So I've just got a little picture right here. And basically, that's not very good, but whatever. So basically, the top is being used in your program. The bottom, which is already configured in the Balluff, that's where the data is being passed. And then, of course, the Balluff is passing into the raw data. All right, so let's open up another program here. Okay, so what I've done here is I have imported, or first of all, I called up Festo product support and said, hey, give me this AOI. And not much to it. You know, they've got some mapping in here. You know, it's really not too much to it. So when you, so I've showed you how to bring in an AOI before, so I've imported the AOI, and you know, nothing in here is going to change at all. The only difference is going to be right here. So instead of, and of course this valve terminal AOI works for all of the Festo valve terminals, and it's not mandatory that you use it. As I showed you before, we already had the valves working. This is just I don't know, it's a preference thing. If you like to use it, you can use it. If you don't want to use it, you don't have to use it. So basically, instead of it being mapped from the top tag to the Balluff directly, they decided to go through their AOI first and then out to the Balluff. So I've got a little picture just to show you. Wrong one here. Okay, so basically now, oh, sorry. Let's see if I can get both on the screen here. This is the other program here. Let me just close this one real quick. So standard procedure here. So they've got the port 2 here, which is the port 2 here. It's being transferred into the individual bytes within this right here, which is the tag that is being used in the Festo Valve Terminal, this bottom tag right here. And then out of that, it's being transferred to the Balluff, you know, right here, showing right here. And that's that. So to me, it's not a good use of code. It's a waste of code to me. But again, that's up to the user whether they want to use it or not. Everything else is identical in the code. And that's it. So hopefully you learn something and accelerate your project a little bit by watching this video. And have a nice day.